So today we're going to go over sections 6.8 and 6.9. On this, our what is to solve equations. So we're now gotten up to the point where we're going to start solving equations. So now our little polynomials are going to equal something. To factor and solve equations using zero products property, using all techniques we've learned so far in chapter 6. And to solve polynomial equations, our y to solve these polynomial equations using the principle of zero products. On that. So we're going to take some notes. We'll probably have some time for classwork. We will not be doing quiz next time because we'll be doing review next time. Remember, you have a test next Wednesday. Test on chapter 6 is next Wednesday, which will be the first time we meet after our break. No, Thursday. Next Thursday. Shh. Next Thursday. So a week from Thursday. Week from Thursday, we have our test, which means our next class period we'll be doing review. Sam, take the chair, sit outside, please. So next time we'll be doing review. And then we will have our test the next time. Means you need to get things. What next Thursday? Shh. You don't have me again until the next Thursday. All right. So in our word banks, again, we need. So we have some of these already filled out. We've talked about binomial expansion. That's what actually binomial expansion is what we talked about last time. So you should have an example. That was that stuff about Pascal's triangles. So you should be right now put in an example of that binomial expansion. This thing we did like a plus b to the 0 power, a plus b to the first power, to the second power, to the third power. This stuff all about Pascal's triangle that we covered last time. So you should have an example, your own example in there. You've had this for a while. No, that's from chapter 5. I gave you chapter 6 a while back. Okay, so you should have most of this stuff, factoring polynomials, all this stuff. Factorization. We've done all this. Today we're going to be talking about the principle of zero. We've talked about things that are relatively prime. But we're going to be talking these principles of zero, some of these things about root, and you guys we've talked about trinomial squares. So you should have examples for all of those except for really these two on here. All right. So make sure you get those filled in for the test. So today, difference between an expression and an equation. The difference between an expression and an equation. An expression is one term alone or two or more terms together with an operation symbol. So an operation would be like this, like x squared plus x plus 5. That would be an expression. We have several things separated by operations. An equation is a mathematical sentence that uses an equal sign that shows two expressions are equal. Some examples. X squared plus 2x equals 83. 2x squared plus 5x plus 10 equals 0. Those would be equations. Notice, what is the big difference between these two? The equal sign. Well, the difference between an equation and an expression? Basically that equal sign. In other words, you are saying this thing on the left side is mathematically the thing same as the thing on the right side. You're saying that those two things are the same. That makes it an equation. And so today we're going to put the stuff we've learned about factoring polynomials. So now we're going to be able to get solutions. And the thing is with these solutions, they may have more than one solution. In other words, x might have more than one value. You know, this is true like when we use this sort of things, the quadratics. This sort of equation, like in physics, is usually we associate with time. The x would be time, and you might get two values. You probably usually get a positive and a negative. You throw out the negative because you can't have negative time, things like that. So you have to review also what your answers are. Sometimes, even though you get two answers, some of the answers are not going to be valid as we go through this more and more. Anyone have a question on this? No. So, we're going to use the zero property. Now let's look here on page 286 of your book. Principle of zero products. Urissa, could you read me that statement, please? Please read me that statement. The only one. The yellow box.
For any rational value.
Hmm?
For any rational number, a and b, if a, b equals 0, then a equals 0, or b equals 0, and if a equals 0, or b equals 0, then a, b.
All right, so this is our zeroth property. It says if a times b equals 0, then a equals 0, or b equals 0. One of them has to equal 0 on that. So in this expression, right here, some examples. If I have 3 times x, I want to know, well, what does x have to be 0? Well, if I divide both sides by 3, x, what's 0 divided by 3? 0. So in this case, x has to equal 0. All right? But in this case over here, now you might say, well, x equals 0 before x is 0. But no, what has to equal 0? X plus 2 has to equal 0. So in this case, since there's only that one binomial, we first get rid of the 3. We get x plus 2 equals 0. Subtract 2 from both sides. So x would have to be negative 2. And if we check it, 2 plus negative 2 is 0. This is why we get those binomials. When we do these things, when we get the binomials, we're going to set each binomial we get when we factor equal to 0. Yes, sir.
So I gotta do the fences first.
What are you going to do with the first?
No, actually, when you're doing equations, like this one, you're going to set it, basically you're going to say x minus 1 equals 0, or x plus 2 equals 0. One or the other has to equal 0, based on our zeroth prop, the principle of zero products. So we say, okay, I'm going to add 1 to both sides for this one, x equals 1, or x equals negative 2. For if we have these two binomials, we're going to get 2. So in other words, with quadratics, since we factor them into two binomials, we're always going to have 2 solutions. Unless, of course, it's a square. In other words, if we ended up with x minus 1 square, both solutions would have been negative 1, that sort of thing. All right, so work the other 2. Let's look at this. So this one, shh, gentlemen, ladies, focus. Focus. Eduardo. All right, remember, this is really A, that's B. Remember, A times B equals 0. A is going to be 0, or B is going to be 0. So we got one solution, which is 0. The other solution would be negative 2, because I'm going to subtract 2 from both sides to move it over. So we could say x equals 0 or negative 2, like that. X equals 0 or negative 2. Two solutions. Sometimes if you had to factor something out first, say, you remember we did some problems where you would factor, say, a 2x before the trinomial, then you might have 3 solutions. But one of those solutions, when you have something like this, one of the solutions is always going to be x. Or it's going to be 0. One solution is going to be 0 like that. So for this one, hang on, I have 2x plus 1 equals 0. Shh. X minus 8 equals 0. So I'm going to subtract 1 from both sides on this side. I get 2x equals negative 1. Divide both sides by 2. X is negative 1/2. Hang on. One solution would be negative 1/2. The other one, I'm going to add 8 to both sides. And I get x equals positive 8. So my two solutions, pardon? Well, I did, but I have to move, before I can divide by the 2, I have to move the 1 to the other side of the equation. So I move the 1 over, then I divide both sides by 2. Emily, you have a question. Then stop talking. You had a question.
Yes, I did. Do you have to put x equals or did you just put 1?
You should put it like this, or. It's one or the other. You should. Yes, you have to. Let's just specify it. You have to.
Now I get it.
All right?